Welcome to my press simulations. My name is Lazarus. Today we show problem statement number 1, ping-pong socket. In the statement, ping-pong ball is placed in a container of water. When the container is dropped, what maximum height of the ping-pong ball can it reach without 2 liters of water? That we need to understand the perimeter deliberately shows in the ping-pong. Our models that contain the perimeter firstly, initial height, study on the trajectory of the balls, and then investigate the automatic perimeter that is close to the ball to obtain volume of water limited in the cup. Let's explain our model first. In the rest of the model, in y-axis, the aquarium beams in the measures. The differentiation of pressure between the ping-pong ball and water will cause the ball moving to the cup. In the following of the models, we can explain net force in these terms that we can neglect the net of initial force, and we can show the credited forms. After that, check performing and using initial transfers and observation of momentum to describe this phenomenon. And finally, we observations, the effect occur in all in the legit world. Finally, we focusing on this statement. We consider the jet of perform with energy transfer. That we investigate parameter of flow in the cut. When the gradient perform, the level of the water is changed. We perform in the geometry forms. We perform the energy of water jet in these equations, and then the volume change of displacement. And simplify conservation of energy in these forms. We can define the initial velocity from this equation too. Based on our model, the character will perform conscious relations between the velocity on the surface. We call like this. In the case, we call energy coefficient. By applying this model to our case, we can approximately show in this case. We can define the height of the jet in this equation combined with comparisons of coefficient energy and the direct force in neglecting. After that, we simplify the model in this equation. Our setup. In the left one in reference point, and the right one is overview of the experiment. To define and to reduce every experiment, we repeat several times the average itself, minimize the angle using flat object. As you can see in this graph, we're plotting in the linear that represent the higher speed, highest or maximum height. That experimental confirms the model well. Then we investigate the parameters of the ball. To evaluate the height from the ball, we use conservation of energy and law of momentum change combined together. We add the laws of mass conservation together, and we can see to get the force functions in the terms, we formatting with differential equation and solve with the method. We will get derivative form of these equations in final. As you can see in this graph, we act in parabolic slide that have the maximum height of the balls, which stops to equal 0. That the graph fitting well. And finally, we will investigate the maximum height of the ball with velocity of diameter and volume of water in the cup parameter. Firstly, heat maximize versus on diameter of the cup. As you can see, when the diameter will larger, the maximum will be limit in some point. We call this jet performing limit point. As you can see by not seeing this model, the frictions of interaction between the ping-pong ball and water jet is breaking by bottom frictions, and we can answer our problem statement from this value. In conclusions, we can perform the force that interact with the ping-pong ball and the water can be explained in this P force function, and reformatting these equations, we can get the height function in height terms. And finally, we can answer our solutions by 2.12 meters. Hopefully you enjoy my presentations. Thank you.